Suppose there's this boy, George, who wants to know which chocolate this girl likes. Out of three choices, which one is most likely to be her favorite? He needs to set up some sort of model to predict the probability that the girl will like a particular chocolate. Let's say that he has set up this neural network with some sort of input and some ReLU neurons in the middle. And then the output layer has three nodes, one for each chocolate. And we have these predictive values of 2, 3, and 5. As you know, that neurons can produce any values. These values are unrestricted between negative infinity and positive infinity. And we're just using 2, 3, 5 as examples, but they can be any number. However, since he needs to know the probability, we really need to turn these numbers into probabilities. This is a classic example of multinomial classification where we have three, more than two classes to choose from. We set up three nodes, one for each class, and we really need to predict the probability for each chocolate. So one very intuitive solution is to convert all these numbers into percentages. We can add these numbers up, 2, 3, and 5. They add up to 10. And then we can divide each number by 10 to get these percentages, 20%, 30%, 50%. They're all between 0 and 1, and they add up to 100%. So they operate just like probabilities. So can we pretend that these are probabilities? Not so fast. The challenge is that weighted sums don't have to be positive. Sometimes they're negative. Here we have a -2. 3 and 5, they add up to 6. And if you try to convert them into percentages by dividing by the total, then you start to see some bizarre numbers. Here we have a negative percentage, and probabilities have to be positive between 0 and 1. So this number cannot be a probability. Here's another bizarre example where we have a total that is -4. So when you have that, you're starting to see not only some negative percentages, but you also have a percentage that's greater than 100%. Again, 125% is okay, but that cannot be used as a probability. Here are 5 numbers. They add up to a positive total. However, one of the percentages is 100% and the other one is -100%. So these are even more bizarre cases. So what's our solution? Well, here comes the Softmax function. So clearly we see that we cannot just take the raw weighted sum values and turn them into percentages. This method does not work. But what we can do is take an extra step by applying the natural exponential function to these values before we convert them into percentages. As you can see here, when we use the Euler's number e as the base and raise that number to a -2 power, then we get a positive number, 0.1353. We can do that with the other numbers, and no matter what kind of number we have to begin with, after this transformation, all the numbers are positive, and we can add them up to a positive total. And now we can divide each number by this total to get these percentages, and they do add up to 100%, and they're always positive. So bingo, this is the Softmax function, and all it does is take the natural exponential of the original numbers before we turn these numbers into percentages. So here's the math formula, and what I have shown you is really a step-by-step explanation of the rationale for the Softmax function, and also an illustration of how easy it is to understand how it works and why we use it. I have also set up a Google Sheet file. So in this Google Sheets, on the Softmax Ideas tab, you can see an example of how the Softmax function works with 3 input values. On the right-hand side, you can see an example of 5 input values. You can see no matter what the input values are, positive or negative, you will always get a set of positive percentage numbers that add up to 100%. Then we can use these as probabilities. So what you can do is you can use this Google Sheets almost as a calculator. You can take these numbers and you can go back and plug them into a neural network. And these are the output values. So we can run them through the Softmax function. You can get their probability values, and then you can look at which one is the highest probability, and that will be the winning prediction for this model.